Hello, hello! Welcome everyone to the stream. David Snowpeck here from Snowpeck Games. Looks like we got a bunch of eyeballs and a bunch of people already on the overlay. Remember, I don't know who's watching unless you say something in chat. Otherwise, I just have an eyeball with an integer next to it. So how's everyone doing today? What are you guys working on? How are your projects going? Let me know while I fidget around in OBS here to get our overlay turned into a proper overlay. Almost there. By the way, this overlay is a game we made in Godot on stream a little while back. Open source, like most of the game dev work that I do. And there. Let me know if that's working. Also, I think the frame rate is better today. Last time we had just a horrendous frame rate. It was like 3 FPS or something. YouTube is not yelling at me, so that's a good sign. Yeah, let's see what's going on in chat. Yep. Thanks, Nisha. Let me know that it's working and the frame rate is good. That is fantastic. Today, I don't think we are going to be playtesting. Traditionally, we started with playtesting, and we've been doing that the past couple of streams, but like, I already know the main problem with the game, so like, playtesting more, I already kind of know what's going to go wrong, and there's a ton of value in testing some more, unless you folks really want to. If some folks really want to do some playtesting, we certainly can, but I think this time we're going to just jump right into trying to fix the performance issues. So before we do that, though, for anyone who is new to the stream, a quick overview of the project that we are working on. This is Retro Tank Party, one of my games. It's a 2 to 4 player online multiplayer party game available on Steam and itch for a very, very low price, especially now. Apparently, there's a Halloween sale going, and it's 27% off. But the game works with relatively naive netcode, very simplistic method of network synchronization. It works good enough. The game is totally fun to play, especially if you're playing against people where you have a relatively low ping. But we have been working for the last several months converting the netcode to rollback and prediction as popular in competitive fighting games and things like the GGPO library. So we are really, really close. Really, really close. Hey, Gauntlet! Gauntlet asks, you mean Steam handles the sales, not you? No, so I do handle the sales, but here's what happened. Steam sent an email some months ago saying, like, here's all the sales coming up. Do you want to have a discount on them? And they give you like a big form next to all of the sales. And I was like, okay, so for Halloween, 27%, for this one, this percent, for whatever, this percent. I'll just have like some random percent for all of these sales. And I'd completely forgotten that the Halloween sale was going on now until I came in here and I saw save 27% on Retro Take Party. So yeah, I can make a sale whenever I want. Steam also has its seasonal sales, and you just sort of like fill out a form to participate in them. Anyway, we are really close to getting the rollback and prediction version of the game done. The main thing standing in our way right now is the performance. So with rollback and prediction, the way it works is you're running the game. When you don't yet have input for the other players, you're predicting what you think their input is likely to be. When you do actually get the input, you roll back to the frame that the input is from, or the tick. I'm trying to make my terminology standardized here. So a tick is like the game simulation, and a frame is like the actual frames rendered on screen. So you roll back to the tick where that input is from, you insert that input, and then you run the simulation back forward to where you left off, which means you could end up running the game simulation a ton of times within a single render frame. And I had it set up before where we were allowing a maximum rollback of 20 frames, or 20 ticks. And I've shortened that. That's kind of a cop-out. I've made it be 15 now, because 15 ticks is approximately a lag of 500 milliseconds. And it kind of feels right to me to say, like, well, if you have a latency of 500 milliseconds, which is a round-trip time of 1 second, that's probably enough. Like, any further than that, it's just going to be impossible to play anyway, right? But it was that rolling back 20 frames or 15 frames, there was a chance that it could actually take longer than the length of a frame to run the whole simulation forward. And so we need to fix that. We need to make the game more performant, and I think we can. I think there's some low-hanging fruit. Yeah, we were working on that last stream as well, and we're going to keep working on it this stream. Let me see what's going on in chat here. The Clean was baking textures for 2 days. Oof, and now I'm burned out. Pun intended. Texture baking, very fun. I imagine you have to do a lot of that if you're making a VR game for the Quest, right? To really try and maximize your performance while still getting like a decent fidelity. So Steam suggests and you approve. Yes. I'm learning GDevelop at the moment. Ooh, cool. But keep an eye out on Godot once in a while. So we were doing game jams at my work, monthly game jams for a while, and one of the developers made his games in GDevelop, and they always came out as pretty cool games. I haven't dug into it very much myself, but yeah, seems like a cool engine. All right, so last time we were trying to improve the performance around generating the hash for basically as the game goes on, we are collecting, we're recording the state of the game on every tick, and if everything's working perfectly, then the state on all of the peers should be exactly the same. And if it's not, that's a bug, and we can't go on. Because the way this works is we're not synchronizing the state between the peers, we're just passing the inputs, and the game needs to be deterministic so that you run the same inputs against the same state, that the exact same thing happens on all the clients. And so we're recording the state, and we need to make sure that our state hasn't gotten out of sync. We're calling that state mismatches in the rollback and prediction add-on that we're building, which will eventually end up in the Godot asset library. And so to detect a state mismatch, we are calculating a hash of the state and then comparing it. Generating this hash is relatively slow. Like, it's not that slow objectively. It takes about 700 microseconds on average, which is fine. Like 700 microseconds, that's like really fast, right? But if you have to do it potentially 20 times in a single frame, like that really adds up and digs into the frame budget that we have. So we were working on, ooh, this is the wrong project. We were working on ways to optimize that, not by making it actually hash faster, because I don't know that there's really a way to do that, by making it hash only exactly when we need it to, right? We're still going to be spending 700 microseconds, but let's only spend that 700 microseconds only when we need to. So before it was like when you would roll back and then roll back forward, it would actually recalculate the hash for the roll forward, which was a problem. And it didn't need to do. Like, if we already had a hash for that state with complete input, even if we're rolling it forward again, like, we don't need to calculate the hash again. We already have it. And we did not successfully on that stream fully get a thing that was working, but since last week, I managed to get something working. I ended up doing something that on the last stream I said I didn't want to do. I'm like, well, we could do it this way, but I don't want to. And it turned out that kind of ended up being the best way forward. So let me just show you that really quick. And I did see some stuff come in chat, and I'll take a look at that in a moment. I just don't want to get too derailed. You guys know me. I am very easily derailed. So before we were keeping track of the hash, I think, on the state buffer frame. I think that's what we were doing. And what I ended up doing was setting up a new thing, like a completely independent buffer to hold the hash. Am I on the right branch? I'm like not seeing the thing I'm expecting to see right now. So there's a state buffer, message serializer, blur, blur, blur. Let me just make sure I'm on the right branch here. I might have switched around to some different branches when I was, I'm on the art packs branch. So I'm derailing myself here, but Ross, who I don't think is coming to the stream today, but frequently on the stream, also a game developer working on an online multiplayer game, Bomb Sorters, but he's developing that in Unity, which is fine. We are open to all peoples here. But he's been making some art for Retro Tank Party, these alternate art packs. So in this branch of the game, you can switch between this SNES art style and the classic art style, and it's looking really awesome. He just added this thing where it's hard to see probably, but you can see the tank treads animate, where in the normal game, the tank treads actually don't animate. You're like driving hover tanks, I guess. Yeah, so I was hacking on that last, I guess. He has some other versions. He did like a vector version of the art and also an Atari 2600 version of the art, which is super cool. And I'm hoping to get that integrated in the game, and probably right after we finish Rollback, I will get that in there. But let's switch to the branch we're working on here, folks. Godot doesn't like it when I switch branches when it's already running, but we're going to try it anyway. We'll check out the rollback performance. Are we on the performance or the performance slush branch? I think I'm working on the performance slush branch. Too many branches. The joy of Git is that I can make so many branches for everything. The problem with Git is that I can make so many branches for everything, and I get very confused about what I'm doing. So let's go look in the sync manager again. I will close this loop, and then I'll check out what you guys are saying on chat. So before, what we were doing is we were sticking the hash not as a property on state buffer frame. I don't know why it should have been a property, but as a special key on data. It was the $ key would store the hash, and then that would be a problem when we were throwing away the state buffer and rebuilding it as we were, rolling back and rolling forward again. And now we have a state hash frame, which keeps track of the state hash, and we are also using it to record the different hashes that we get from the different peers so that we can do a non-debug version of state mismatch checking. So right now we're just doing this debug version where we're sending the hash, but we're also sending the whole state so that we can print these really nice debug messages saying like, okay, the state doesn't match, but actually like here's exactly the key that it doesn't match on, so we can try and debug and figure out determinism problems in our game. And having a separate buffer for that just turned out to be the solution. So now when we roll back, we are wiping out the state frames and rebuilding those, of course, but we are not rolling back the state hash buffer, which I think is what it's called. Did I call it state hash buffer? I called it state hashes. State hashes. So we have a state buffer and state hashes, and basically as soon as we know that the state, a particular state is input complete, we calculate its hash just the one time, and we spend that 700 microseconds just once, which can, of course, still potentially be a problem, because if we're getting complete input for a state frame all on the same render frame, like maybe we're doing that 2 or 3 times, but not 20 times, right? So that thing is sorted. Let me go see what's going on in chat. The clean. I've messed up the resolution, but here is a video. Okay, let me get the video up so everybody can see. How do I do my things? I will find chat on this computer and try to bring it over. Where's my Firefox? Oh, didn't work. There's this thing where like Firefox will open in the last like window that was focused, so I'm like, focus this one and switch over. Didn't work, but that looks cool. So we are seeing that looks like the lightsaber, and here's the robot shooting, and I guess you're reflecting the shot in a couple of bounces there. That looks cool. All right, let's get Restream chat back over here. Turn the overlay back on. All right. The Gauntlet. What version of Godot are you using today? I am bouncing between Godot 3.3.4 and a random Git hash of 3.4 pre-release. I think it's something slightly before RC1. I'm not sure. Who do we got here? Want to become famous. Here comes some of that wonderful Twitch spam. Yep, I am not buying followers or viewers. Sorry, Lucas Alonso. All right. So that state hash thing, got it working. I've been doing just like a ton of like injecting little profile things. I had the this sort of path I was chasing down where I had basically disabled everything in physics, and so just ran everything with no collision, and was timing how long these rollbacks were taking, and they seemed to still be taking longer than I thought they should. In particular, the bullets, when you're shooting bullets, it is a SG Area 2D, so our version of the Area 2D working on fixed point math. And is this still with... Okay, so I guess I re-enabled collision. And all it's doing is like adding a vector to the position, and even disabling the checks for collision and everything, it was still taking longer than I thought it should. So what I started going down was trying to optimize just setting that fixed position property. Oh, here you can see some of the timings going by far too fast to read them. And let me go to that. So actually, no, let me give an overview first. So just updating our fixed properties is one thing that I want to improve the performance on. I've already done some work on it. It's already faster, but there's more that we can do. I will talk about that in a moment. The other area that I think we can improve performance, this is all stuff in our custom deterministic physics engine. Hopefully that's interesting to you guys today. I didn't pre-warn that the performance things I was going to go down was in the physics engine. But the other area I think we can improve is the broad phase. So in physics, the broad phase, basically, the purpose of that is rather than saying, okay, I have this object and I want to see what it collides with, rather than having to check, every single other object in the scene, you're able to say, well, first, what objects are near me? You ask the broad phase, what objects are near me? And our broad phase works by breaking the space up into a grid and keeping track of which objects exist in a grid cell. So the first thing you do is you say, well, I'm interested in an area this big, give me all of the objects that exist in grid cells that intersect with that area, right? And our broad phase is pretty fast, but I think there's some improvements that could be made. And then our implementation of move and collide and move and slide, I think could also be made faster, although I suspect that just making the broad phase faster will also improve the performance there. So let me show you this test project that I made. I've actually added it to the repo for the physics engine, which is, of course, is open source, like all of my stuff. Let's get over there to SG Physics 2D. So I made this demo. I have a couple of demos in here where all I'm doing is spawning a ton of SG fixed node 2Ds and having them move around. All it's doing is adding a vector to the fixed vector. So let me show you the actual code here. So we have fixed position, which is our special fixed point position for our special SG fixed node 2D nodes, and we're just adding a vector. Every frame we're adding a vector, and we are timing how long that takes. And right now, to sort of set a baseline, we have a cumulative average of it running at about 6 microseconds. Again, this sounds so stupid to be worrying about microseconds, but it actually totally adds up. So before I started doing the performance work here, it was taking about 13 microseconds. And now imagine there are 10 bullets moving in the game, because we're in a really active match. 10 bullets are currently existing and moving. Let me get up a calculator. We will use Python as a calculator because more people can understand that. Or wait, I always forget I have that bar at the bottom of the screen. So let me clear and then start Python. Okay, so imagine we have 10 bullets currently in motion. They take 13 microseconds to update their position. That's 130 microseconds. And now we're doing a rollback of 20 frames. That is now 2.6 milliseconds. And if our frame budget is 33 milliseconds, like 2.6 milliseconds is actually like a pretty sizable chunk of our frame budget. And if we can reduce that, now it's already down to 6 microseconds. So that's, this times 16 times 20. We've already cut it in half, basically, down to 1.2 milliseconds of our frame budget is just adding these stupid vectors to each other. And I think we can get even faster. I think we could get this down to the 3 or 4 microsecond range, which would be great. Hey, Samuel Harrison. I also love open source developers. Open source is very important to me, very near and dear to my heart. I've been doing open source since the late 90s. So let me show you kind of what I've already done in this area. Let's get to our SG fixed node 2D. Get to our CPP here. So the code originally, geez, let me just grep in here a little bit. As set fixed position, we have too many things that are named set fixed position. Let's find the one I want. Okay, so originally the way that this worked is we'd set the fixed position. We would also set it on the, we had a local fixed position variable. We also have this fixed transform. So we would set it on the fixed position variable. We'd also set it on the fixed transform. And we would also do this thing where we are like updating our local, everything on the transform. So we would update it, and we'd also say, okay, well, we've changed the transform, which means we need to update our local copy of the rotation, our local copy of the scale, and do all of these things. So I'm like, no, let's get rid of our local copy of the fixed position. Let's just use the origin on the transform. Everything's just going to be set to the transform. And when we need the rotation or the scale, we're going to create those on the fly, which is mostly implemented. And got us down to like from 13 microseconds to 6 microseconds. So cool, we're heading in the right direction. It doesn't totally work. The scale, we are calculating it on demand, but I broke the thing where you could like update the scale property and have it like actually update things. You have to get the scale property, change it, and then reset the scale property, which wouldn't be terrible. Like I almost was just like, well, let's just have it work that way. But that would mess up the way that we are having the properties work. So like, let's get the inspector going here. It's like in order for a scale to appear in the inspector, our fixed scale, like it needs to be its own property. We need to be able to update stuff on it. And I don't know, that's important. But right now it's broken. So you change scale, it won't actually scale the object. So we need to fix that. The reason that it's broken, actually, let me just show you that really quick. SG fixed vector 2. We used to have a signal on SG fixed vectors. So every time the vector changed, it would fire this changed signal, and then we could connect to it and use that to like know that it updated and do stuff. That is actually the source of the biggest performance problem. So we originally had, so we would change a property. Where would that be? Maybe it was in here. Right, so we would do like iadd, that's in place add, and we previously had down here emit signal changed, right? Which even if you only do GDScript, that should look super familiar. The C++ API of Godot and the GDScript API are actually very similar. The GDScript is kind of just like a layer over the C++ API. And that added like most of the time that we were saving just emitting a signal. And so what I did was like, well, I'm just trying to see what I can do to improve things. Let's like explicitly add a thing to SG fixed vector that says like, well, when it's changed, if you've registered this position owner, like call fixed position changed. And that got us like all of that performance improvement. So what that has taught me is we cannot use signals. We cannot use signals for things that need to happen this often. The performance cost is just too high, but we do need some other way to get like changed information. So we're gonna have to come up with our own little system, something that's more generic than this position owner thing, which I just hacked in here. The way it is we have a pointer to an SG fixed node 2D, which SG fixed node 2D just like sets itself because I made it a friend, and then it calls directly to a particular method, which totally isn't gonna work because we're gonna need to be able to also on the scale vector have it call back to the node 2D. And then I also discovered that we were using this somewhere else. We were using it in our shapes. I think in SG shapes 2D, in the rectangle shape, we have an extents vector. And every time that was changed, we were using that to also fire the changed signal on the resource. That's kind of how where you're changing something in the editor or wherever, that the editor or other things find out that a change has happened, and in the editor that'll like redraw the shape or whatever. So we need a generic system, but not one that uses signals. We need to do something purely in C++. And I'm not entirely sure how to do that. I have a couple ideas. The reason that I'm not entirely sure is that function pointers in C++ like totally suck to work with. They just totally suck to work with. What I would love to do is to be able to say like, we'll just pass in a function pointer, and we'll have the object call that, and that would totally work. But like, I don't know. Maybe we'll do that. Maybe we'll figure out how to do it. If anyone here is like hardcore in C++ and can help me navigate around function pointers, like that would be sweet. But I have a feeling we're going to have to do something a little bit less fancy. So anyway, that's the one thing we gotta fix. We gotta fix this. How we're getting this information about when something has changed. And the other big thing, which I think will be huge, is that every time we are updating our fixed position, let me get back over to fixed node 2D, we are also updating the normal position, the position property from Godot. And during a rollback, we don't really actually need to do that. So let's say we've rolled back 10 frames, and now we're rolling forward 10 frames, like really fast as we can. So we're updating fixed position 10 times. We don't actually need to update the normal position 10 times. We only need to update the normal position right before we render. So all of the code that happens here, which is actually non-trivial, we call this update xform values, we call update transform, notify change doesn't matter, that doesn't run at runtime. But like this does a bunch of things. It's doing some matrix math, getting a rotation, getting a scale, getting the scale as we all should know by now after battling with this for weeks and weeks, is doing the Pythagorean theorem. That's you're squaring two numbers, adding them together, and getting the square root. So that's slow. That's slow. We don't need to do that every single time, so let's not do it. So those are the two things I want to do to this. I want to come up with how we're going to deal with this change signal, and then also come up with a way to delay setting the floating point position until right before we're about to render. And I think all those things together should get us down to like 3 or 4 microseconds for this call, which is going to be beautiful. Like 4 microseconds would be cutting our original time we were spending on this during a 20 frame, well during however many frames would be cutting it into a third, which is awesome. So let's dig in, guys. Let's make this happen. Burring, at this point, do you think internal changes to the C++ code will improve performance enough, or do you think moving some code from GDScript to C++ or C# will be needed also? So this is something I've also been thinking about. Thanks, Ricardo, for the question. I've gotten to the point where I do not think we can make the sync manager, which is like sort of the main component that manages rollback and prediction for us, in GDScript any faster. I just, maybe we could, but like, I just don't see a way. I think that's as fast as it's going to get. I think there's still some things we can do to our gameplay code to make it faster, like the tanks network process method, I think could be made faster. But I think the only way we'd be able to make the sync manager faster at this point would be to convert it to C++ or even C#, right? Which should be fine. Like, this is a component that developers will just be using. But I don't want to do it right now. I want to do everything I can to avoid converting it into C++ or C# or something until later. What I'd really like to have happen is that we get the sync manager working exactly how we want it. We have it running in a couple of different games, so we know the API works, we know this structure works, and then at that point, like, well, maybe we could convert it to C++ and get like the extra performance benefit there. So I've kind of reached the point where I don't think the sync manager can get any faster without converting it to C++, and I don't want to do that now. I would love to be able to launch the new version of RetroTank Party without doing that. But I can already see like a whole bunch of things that we could do in the physics engine that's already in C++ to make it faster. And so let's do those things. And I'm hoping, I don't know for sure. Your question, will internal changes in the C++ code improve performance enough? I hope so. I really hope so. I'm betting on it. And if it doesn't, next week we'll be converting the sig manager to C++, but I hope we won't be. I think I'm very hopeful this will be enough. So let's dig in. I've maybe two kind of ideas about how we can do the change signal. One involves making an abstract class, and the other involves making a C function pointer, because I don't want to deal with C++ function pointers. And let's just pick one. Let's just pick one and try it. Maybe let's start with the abstract class. And I don't know which one is better, honestly. Like, we'll have to profile it and see. Maybe we'll do both. Maybe we'll do both and profile them. So the abstract class, the way that that's going to work, we're going to go to, I guess, SG fixed vector to the header. And we're going to, why is my keyboard not working? There we go. We're going to make an abstract class, which will be sort of like, we're going to treat it like an interface because there are no interfaces in C++. We'll call it like SG fixed vector to monitor, watcher, something like that. This will be a class that wants to keep an eye on what's happening to a SG fixed vector. And it's going to have a single virtual method, which will be like, I don't know, fixed vector to changed. And we'll want to pass in a reference to the vector so that we can watch multiple vectors and figure out, well, which one changed, which is going to be a constant. Constant reference to SG. Ooh, well, actually, we'll have to define this below this class. SG fixed vector to vector, and I guess it needs to be public. Why are you yelling at me? What am I doing wrong? Okay, cool. So what we're going to do is we're going to have our SG fixed node to D descend from this abstract class, implement this method, and we're going to have a thing similar to our position owner here. I guess we have to do a little forward declaration. SG fixed vector to watcher. And I guess I'll get rid of this because we no longer need to tightly couple. SG fixed vector to watcher. We'll say watcher. And we'll need a way to set that. But basically, yeah, when something changes, we're going to say, is this watcher not null? And if so, call that method on it, and hopefully good things will happen. All right, so we need a method to set that. I guess I'll put it towards the top. We have kind of like these sort of getters and setters at the top. We'll maybe do it below all of the kind of basic properties here. So this will be force inline, since we are just setting a value. This is kind of just giving us encapsulation. Set watcher, vector to watcher. And I'm going to treat this as const because we want to be able to do this to const things, which means we have to declare this as mutable. I always forget, does mutable go before the variable or after? All right. VS Code isn't yelling at me, so we'll hope that's valid C++ syntax. And so we'll do watcher, p watcher, bam. And let's go over to the implementation side. So here, instead of position owner, we're going to do I already see a problem in this implementation. Okay, so watcher needs to call fixed vector to changed, but we don't have a ref. We have the actual object, which is this. But I think that's okay. I think ref allows us to access the pointer, the real underlying pointer. Let me just find something that has a ref in it so I can use the auto completion to help me answer this question. Come on, something's got to have a ref. Here we go. This one has a ref. So we'll say p other get ref pointer. I think that's what we want. Let me just jump over there. No, is this what we want? No, this is reinterpreting it to a reference. Okay, not ref pointer. Pointer. I think this is what we want. Just this PTR. Yeah, so the underlying reference in ref is there. Okay, so let's rewrite our code a little bit to deal with direct pointers to the vector. And let me just make sure that that PTR looked at was public. Yep, looks like it is. Okay, so delete that bit of junk code. Hop back over here. Our watcher is going to take a const reference. It's going to take an actual pointer. Cool. Yeah, okay. Something I always forget to do in C++ because I don't do C++ very often anymore is I always forget to set things in a constructor. Ricardo says, makes sense. Seems like a good strategy. This optimization of not necessarily updating the float position seems promising. Yeah, I think that will get us the biggest gains for sure. I'm excited to see what happens when we do it. I'm not entirely sure how to implement it yet. We'll have to find the right place in the rendering kind of life cycle to do the update. And that's going to be the challenge there. Okay, so fixed vector 2. Was I still messing around in the header? Or not? No, I think that's all I need to do to the header. And then let's get back to this. Fixed position changed. Not that one. The first one. The first one is messing with the watcher here. Okay, and we're passing this. Okay, so that works now. And we just have to make that same change everywhere. Watcher. Here, actually, let's just copy and paste. And we'll search for position owner. What did I do? Okay. I use the Vim key bindings in VS Code, but they do not work exactly like Vim in like this tiniest, subtlest ways that make it really irritating. And I guess if I primarily used VS Code, my hands and brain would get used to the VS Code version of Vim key bindings and not the real Vim version, but I mostly use Vim itself or the Vim key bindings in PHP Storm, which are, I guess, closer to the actual Vim key bindings that it doesn't bother me as much. All right, so that should be enough in this class. Let's jump back over to SG fixed node 2D. And now we need to have this use multiple inheritance, the sacrilege of multiple inheritance, which honestly I would say is mostly never okay. It's mostly never okay to use multiple inheritance, but we're using it here as kind of a stand-in for interfaces, which to me feels okay. That feels like it should be allowed. And so we need to now implement this new virtual method. Where should we put it? It's a public method. I kind of like to put these internal things sort of towards the top. But no, I'll put it low. People don't need to see it so often. Okay, so that was void. What I wouldn't give for PHP Storm's autocomplete of parent methods here. What did we call it? Fixed vector 2 changed. And that is an SG vector 2 pointer. That was all it was. It should probably be marked const, which means I have to go change this elsewhere. SG fixed vector 2, there we go. Jump down here. This needs to be const. case we're passing around any const pointers. Although, is it const? No, it's not const, because we are changing ourselves when that happens. Okay, never mind, take it back. Hopefully that won't bite us later if we're passing around a const pointer. Of course, in C++, all of this stuff like const is optional. There's ways to get around. You can definitely change things that are const by breaking the rules in pretty well-known ways. Let's get over to where we need to change this again. Come on. I got rid of the const there. Did I get rid of the const here? No. Okay. SG fix no 2D. Okay, so now we need to implement that method. Oh, we also need to get rid of all these position owner things. So we'll say set watcher this, set watcher this, and we'll implement this method, which I will copy and paste from the header. And here we go. So now we need to figure out which vector it is. So we need to say if p vector equals the position, which is just the origin of our fixed transform, pointer, then we need to call what we were calling before, which was fixed position changed, which actually we probably don't even need that method anymore. We can probably inline its contents over here, which will give us a slight performance boost. Very slight, but whatever. I'll take every bit of performance boost I can get. Actually, the performance increase of not calling a method when you are compiling for the web is higher. Oh, this needs to not be arrow, this needs to be dot. There we go. So let's find this method, completely delete it. Oh, I'm using it elsewhere. Ah! Okay. Never mind. We'll keep this method, although it's so simple. It's so simple. And we're going to totally change the way we do this, actually, really soon. We're going to get rid of this set position. So, yeah, maybe I will just duplicate it. I'll just duplicate it. It's fine. Where was the other instance? It's here. We'll duplicate it. And I saw that this was bound here. That's probably from when we were still using the signals. And that should be good. Okay, so I think that's enough. I think this should work. Let's compile it. Let's see what the compiler yells at us about. Always. What do we do while we're waiting for compiles? So I don't know if you guys are following. Oh yeah, I need to fix this later. What's going on with Opengl in Godot 4.0? Hugo Kalinau is working on a. Did I lose my Firefox? Is working on a PR to bring Opengl support back to Godot 4.0, which I'm super excited about. The plan, which is still the plan unless Hugo manages to finish this like really soon, is that Godot 4.0 would be released without Opengl support, only Vulkan, and Opengl will be added back in 4.1. But the implications of not having Opengl support means no WebGL, no HTML5 export, and that just would really suck, having no HTML5 export in Godot 4.0. Of course, it's fine. People who want Opengl can keep using Godot 3, but it limits its reach. Like, no one's going to use it for a game jam if they can't make a... Get out of my way, terminal. So I'm really excited. I'm hoping that that does manage to get done in time. And if it does, we're going to have to change the topic of our streams dramatically. Because if there is suddenly 3D WebGL support in Godot 4.0, I'm going to have to drop everything and start working on WebXR support for Godot 4.0. Okay, so it seems like that worked. None of these things would be moving if what we just implemented didn't work. So Let's just take a peek. What? Was that even faster? That doesn't make sense. It shouldn't be faster. Let's let it run for a little while longer. Let's let it accumulate some more data. Move, my little boxes! Yeah, as the maintainer for WebXR support in Godot, I don't want WebXR to disappear in Godot 4.0. I mean, if it has to, it has to. Fine. We'll bring it back for Godot 4.1. But I would just love to have it be in the initial release of Godot 4.0. So we'll see. Okay, so that was doing about 4 microseconds. There's also a problem here with this sort of profiling that, like, as the load on my computer changes, we'll get different results. I can't imagine that that's faster, though. In what universe would that be faster? We're doing the same thing. We're like, we're holding onto a pointer. We're calling it directly. Why on earth is that faster? We went from 6 microseconds to 4 microseconds. I'm going to do it again. Run, my little boxes. What are we getting? Yeah, we're getting around 4 microseconds. I have exactly zero clue why that should be faster. If anything, it should be like microscopically slower, because now we're hitting a virtual table and checking, like, you know, equality of these 2 pointers. Of course, it's just checking 2 integers, but still. Interesting. Interesting. Let me just see if there's any updates on this PR while I'm thinking about it. No, still Juan's qualms about the name of the... I am thoroughly confused. These shouldn't have changed. I guess reload. Oh, because this is the other window. Okay, close you. All right, so that worked. Let's take a look at the diff and just commit that if it looks good. And then let's move on to the other thing, the possibly more exciting thing of deferring updating the floating point position until it actually needs to be rendered. I actually wonder if inlining this function maybe is the thing that made it faster. I don't know, just mysterious, very mysterious what happened there. Oh, and you know what we should do? That's just weird why this stuff would change. Oh, because I'm in the wrong project. Okay. Oh, I'm so confused. Okay, so I'm working on the Godot project in this folder, but I'm actually working on the C++ code in this folder. I've been copying it back and forth, giving myself a weird split brain thing. Okay, so let's commit that. Seems good. I'm going to need to copy. No, I'm going to need to copy Godot modules. How is this laid out? Okay, I can copy this to and hop over here. Now we should get a diff. Now we've got a diff. This all looks good. It doesn't actually fix the scale problem. I should maybe do that next before we switch gears completely. We will stop tightly coupling SG fixed vector 2 to SG fixed node 2D. And that's good. And let's fix the scale thing, which basically just means using that same mechanism to get scale updates. So let's get down to where we are creating our scale, fixed scale object here. I'm going to, set watcher. Why isn't it giving me, why are you not auto-completing for me? Oh, because I'm typing get, not set. All right, set watcher. This, and now we need another branch up here where we check else if p vector equals fixed scale pointer. And we need to do a couple things here, don't we? Yeah, so this one doesn't need to update anything in the underlying transform because this is like literally part of the transform, so it would have changed on its own. This one does. We need to do set scale, first of all. P vector get, or toFloat, that's what we called that, toFloat. And we need to update the underlying scale on the fixed transform. So that'd be fixed transform. Set scale? No. What is it? What is it called? Oh, you know what? I bet we have to first convert that to our internal object, not the wrapper object. Okay, so that's SG fixed. Wait, we should be able to take advantage of some code we already wrote. Let's go look at what we're doing when we're just doing set fixed scale. Okay, so yeah, we basically need to do exactly this code. Let's just call this method. Let's just call this method. It does one superfluous thing. No, it actually doesn't. Right, because we're not keeping fixed scale up to date anymore. So we can, the one superfluous thing it's doing is this error check. Okay, cool. We're gonna just call this method. Save us some time here. We'll do set fixed scale, and we will just use our fixed scale property, and it's going to do all this stuff for us. Okay, cool. Let's compile this. I don't have a way to test the scale in this demo, but we can test it by using the zap power-up in RetroTank Party. So let's recompile here, and then we'll just switch over to RetroTank Party. Compiling. Anything going on in chat? Not at the moment. You guys excited about anything in particular with Godot 4? I mean, we're like days, maybe weeks, but close. We're very, very close to Godot 4.0 Alpha 1 coming out. And it's exciting. These are exciting times, my friends. I'm also excited about the new tile map editor. That's going to be really cool. There is some cool stuff coming in networking. Some of it I'm excited for, and some of it I'm like, man, I'm never going to use that. The thing that I'm probably never going to use is there's this like scene replication thing that Fales and the rest of the network team have been working really hard on, and it's cool. I think it's going to be great for people who are not experts at networking to do networking with much less effort to make network multiplayer games. But I don't think I'm going to use it. I think I'm going to still keep doing basically what I'm doing. But some of the things that I am excited about in networking in Godot 4 is the changes to eNet. Fales actually just wrote a blog post about it on the Godot blog like 2 days ago. But it's now possible to make mesh networks with eNet in Godot 4. So you have to do a bunch of stuff yourself that you don't have to do in WebRTC. WebRTC, you also make mesh networks. But it allows you to use real UDP on a mesh network, which I'm really excited about. And I don't think this is going to be possible right away, but I think it should be possible eventually if someone wants to do the work, and maybe I will, to make a mesh network that includes both eNet and WebRTC connections, which I think could be amazing for something like RetroTank Party, where WebRTC actually kind of slows us down because it's got that what's the word? Flow control. It's got that flow control algorithm that is not good for rollback and prediction networking. It's fine for games that don't need to send something every single frame, but definitely a hindrance for games that need to send something every single frame. And being able to say like, well, no one here is using HTML5, so like let's just not use it. Let's just directly make UDP connections. So that would be really, really cool. And then if someone is playing via HTML5 and they join the match, like, okay, so to that peer, everyone makes a WebRTC connection. What am I doing? I am trying the game and the Zap power-up because that changes scale. And I know from trying it last night, it was totally broken because of those scale changes. Let's see. We want ability, Zap. Let's see if we work. Hey, we scaled! We scaled! Scale problem solved. Okay. The Clean is excited about multiple window support. Yeah, so I have mixed feelings about multiple window support. So like, I actually like that everything's in a single window in Godot because of my window manager. If it was spawning windows all the time, with my window manager, it would be so annoying. It would like, there'd be like a little dialogue would come up and it'd be like, brr, take over the whole screen. So like for the most part, I kind of don't want that. But then again, for the script editor, I would love to be able to bust out like one of my scripts on this screen and another script on this screen. That would be amazing. So I don't know. I don't know how configurable that's going to be. If it's possible to do the kind of thing, it would be nice for me if I'm just going to keep doing things the way they are. Vulkan is a game changer too. Yeah, sort of. I mean, yes, but like at first, we're going to be trying to get back to like usability and performance that we had before. I mean, maybe it will be more performant out of the gate. But yeah, I think that's more of a long-term play. Vulkan's going to be great for the next 10 years of Godot, and maybe, at least in my opinion, not going to be that big of a deal for the first year that we have Godot 4.0. We'll see, though. We'll see. I think it'll be really important in the environment you're working in, the Clean, on the Quest. Being able to do Vulkan on the Quest should be much better performance than doing OpenGL on the Quest. And Ricardo saying faster multi-threaded physics, I think. Yeah, I haven't heard much about threading in physics. I mean, Godot's physics engine is already multi-threaded in Godot 3. I haven't heard much about those changes. I've been mostly just following as is it Camille? Or I'm not sure how to say his name, but I think he's the one who's doing the physics stuff, right? Pooley Ketchup on GitHub. I'm way better at remembering people's like GitHub names than their real world human names. But I've been mostly following as he's been filling in the things that were missing from the Godot physics engine that we had in Bullet. So I'm excited about not using Bullet. To be completely honest, I'm very much looking forward to that. Whenever I'm trying to do like VR physics stuff, like I constantly have problems with objects falling through other objects. Because like the CCD, at least the way Godot is doing CCD with Bullet is just not working. It's just totally broken. Anyway, we fixed scale, so let's commit some stuff. Let's commit some things here. Oh, let me make this terminal bigger. I didn't realize I hadn't done that. Oh yeah, I have to copy the things over. Diff. There we go. Oh, it's just like a 4-line diff. Okay, fixed scale updates. Now let's see what we can do about updating position at the last minute. So first we need to do a little bit of research here. We're going to need to look at the order that Godot is doing things in its normal frame update, in its normal like game loop. And I forget exactly the source code file that does that. Let's close out all these things. I think... Okay, well, let's get out of here. I just need to look at Godot's code. Oh, come on. How many folders do I have expanded? Does anyone know the way to unexpand all in this like file system view in VS Code? That would be super useful right now. Okay, just close everything. All right. I think we are looking in... It's either scene... No, I don't think it's seen. That looks like all node stuff. Main. Possibly main. Let's go look in main CPP. You know, I just have a terrible memory. I need to... Wait. That actually looked... Here we go. I think I'm actually in the right spot. I very inadvertently got to what I think is the right spot. Okay, so iteration. This is where we want to be. So setting the frame step, physics interpolation, input buffering. Ooh, cool. Okay. Don't get distracted. Don't get distracted. So get main loop iteration. We might need to be stepping into here. Idle. Singleton draw has changed. Audio engine. Let's go see what's going on inside here. Of course, we won't know which main loop. We'll need to find one. Main loop is scene tree, right? Scene tree. Let's go look at what scene tree descends from. Scene tree timer. That's not the right thing. Scene tree H, that one. Oh, okay, no, that's just a class at the top. Okay, yeah, so scene tree descends from main loop. And we'll need to, what was that method? Need to look at iteration here. So let's look at scene tree. Iteration. All right. Okay, perfect. This is exactly where I want to be. So, normal iteration happens. We admit the signal physics frame. Notify group pause. What I want to know is, okay, so all of our work is being done in physics frame, right? So we're going to be updating fixed position over and over again in physics process. And then process is going to run, or process runs before it. I'm actually not sure on the order of those. But I think we want to update the floating point position right before process runs. Unless process runs first, in which case we want to run it right after physics process for all nodes completes. Or not for all nodes, for the node in question, right? Because we're looking at it overall, but we're really going to be doing our implementation for a single SG fixed node 2D. So this flush transform notifications thing has me thinking we also need to have our stuff happen before this happens. Okay, where the heck is physics process being actually called? So notify group pause, call group flags, viewports. Okay. Pause, physics process. What is this notify group pause? What does this actually do? Okay, so this is actually calling a particular notification on all of the nodes in this particular group. This may be where our stuff is happening. I need to get back to where I just was. What notification is this doing? Iteration. Notification, internal physics process. Okay, so internal physics process is happening, and then physics process is happening. And then flush, what is this? Something group something. We need to run, let's say we want to run right after physics process completes. This is sort of convoluted. Okay. We have our sync manager. Let me draw a picture. Pictures are good. So let's make a new thing here. So our scene tree has our singletons over here. One is our sync manager. And then over here we have the actual root of our scene. And actually I should have written this back the other way around. Because the scene tree runs from left to right. As far as execution order. I lost part of my T. Okay. Forget you, part of T. I will add you back. Okay, so our sync manager is a singleton over here. The root of our scene tree is over here. Everything on the scene tree runs in scene tree order, which is top to bottom, left to right. Or you could, if you visualize the scene tree the way it is in the editor, like that's still, I guess, top to bottom, right? That's the same thing. But so the autoloads are always before the root of the tree. So our sync manager's physics process will run first. And that is actually what calls the network process on all of our nodes. So then we get to the actual nodes in our scene, which, we'll just pretend there's two. And one of them is going to be an SG node 2D. And this one is whatever. Who cares? So the way this is going to work is physics process is going to run here on sync manager, which is going to call into the network process on this node, and that's going to update fixed position a bajillion times. And then later in the process, this node's physics process is going to be called. And I think that is an appropriate time to do this, right? That makes sense. We need it to be after the sync manager does its physics process and before this flush transform notifications happens. I think that could work. So we could do it either in physics process or internal physics process. And from C++, is there a meaningful difference between those? I am not sure. Let's see if the docs give us any insight here. What was it called? Notification internal physics process. Notification internal physics process. Hey, someone asked, and last year too, not outdated information. Yeah. What is the difference between those two notifications, between physics and internal physics? Internal physics processing happens in isolation from the internal physics process calls and is used by some nodes to internally guarantee proper functioning even if the node is paused or processing is disabled for scripting. Only used for advanced uses. Okay, so I think we want to use the internal one, right? That sounds right. If the node is paused, well, no. So the sync manager should also respond to the node being paused, to the game being paused, I think. Let me actually verify that. Are we doing anything? Let's get a Godot running here. We're doing anything in the sync manager to ensure that it keeps running when the game is paused. We might be, actually. Because when the game is paused, do we still want ticks to happen? I'm not sure. I'm not sure. I haven't thought this through unless I have and forgot about it. Which happens a lot. Okay, so the sync manager. Doing anything in here with regard to pause behavior, pause mode. Okay, so the ping timer. I forget the meaning of each of these enums. Continue to process regardless of the scene tree pause state. Okay, that makes sense. We want to always be pinging even if the game is paused. Keep pinging. So far, so good. We're not doing anything else. So that means that the sync manager itself will pause when the game is paused. Does that sound like the right thing to do? I think so. I think so, because if the game is paused, we don't want to keep generating ticks. Currently, the only time we ever pause is during match setup, because we want to allow all of the peers to set up the game entirely before we say, okay, start the game. And then we start running all the ticks and everything. So I think we want it to pause. Okay, so sync manager should pause. What does that mean for SG fixed node 2D? If an SG fixed node 2D, if that node is paused, do we want to still do this? And also, the pause behavior isn't the only thing, too. It's this set physics process. Okay, to guarantee proper function, even though it's paused or processing is disabled for scripting. Let's just do the internal one. I've never used it before. Let's use a thing and learn how it works. See what it does. If it fails, it fails. We'll try the other way around. Sound good? I haven't been watching chat. Let me get my little Chromebook going here. All right, so where is VS Code? VS Code is here. We'll get to our fixed node 2D. Do we already implement notification? We do not appear to. I always forget if it's protected or not. I think it is. Where's something where I know we're implementing notification? Collision object, I think. Notification. Yep, it's protected. We'll just copy this. I actually been meaning for a really long time to look into how notification is called, because it's not via like normal inheritance and you know, like a virtual table or something. It's doing something special. Something special and custom in Godot. All right, and copy it again. Jump over here. All right. We'll do what notification always does, which is big switch statement. Notification internal process. I still don't know the relationship between physics process and normal process. Like which one runs first? I'm super curious about that. I'm just gonna try and figure that out really quick, unless somebody knows. In which case, tell me please. So main loop iteration happens first. And all it does is call the iteration on the script instance, which I think that's what calls the GDScript version of all of these things. So that doesn't answer the question at all. I do not see where normal process is being called. I'm sure it has another like enum for it though, so let's just find it. It's notification process. Let's grep the code base. Where's my Godot source? Notification process. Oh, and that's going to give us for all the nodes that are implementing it too, not just where it's being called. We'll see if we get useful output. We might need to restrict our search a little bit. In my mind, physics process should happen first. In my mind, what I imagine happening is that physics process runs, and then we run process as many times as we can until the next physics process frame needs to run, because it's on a fixed timer. But, oh, geez. Okay, I should have piped that to less. Let's pipe it to less. But I don't know if that's actually true. And it's the process where things are going to be actually drawn. So we need to make sure that we're syncing to these float properties after we do all of our fixed point updates but before process starts running. Here we go. Did I just like skip over this? Line 528. 528, go! Oops, wrong file. Okay. 528, go! Idle. Okay, so when is idle called? Okay, thank you. That wasn't what I wanted to know. Find all references. Jeez. VS Code. I need to learn you better. Scene tree idle. Something else externally must be calling it. Let's... Maybe VS Code will like me better if I look for references for the parent class. Okay, forget you, VS Code. We're going old school. We're grepping. Let's grep for main loop arrow delimabob. Just think I have to put a backslash in front of idle. Clean. Process before physics. Really? Interesting. So, do you have the code reference, the clean, for that? I'd really be curious to know, because does that mean it's running process like... It just seems hard to do that from a timing perspective, right? So for every single frame... Or no, another way of looking at it is that every frame you're going to maybe run physics process once, depending on how much time has passed from the last physics process, but you're definitely going to run process. And I've always sort of thought of like physics process is for updating your simulation and process is for updating your visuals, but that like model totally doesn't work. If these run in the opposite order. Okay, my grep found nothing. I'll try a different way of grepping for this. I don't know if you guys can even see this. Probably not, because the bar at the bottom. And it's tiny. Let's make this bigger. All right, that's a different idle. We might be waiting a bit for that. So much waiting in C++. Okay, scene tree, yep, okay, so that's our definition, but where are you being called? Where's idle being called? Main timer sync? Saw it in the docs somewhere. Okay, yeah, I mean, the docs are usually right. The docs are mostly right. So, oh, here we go. This looks promising. Okay, this is the spot. 2186 in main CPP. Let's check it out. Okay. Yeah, I don't know if you guys can tell. I've been doing open source for so long that like I go to the code before I go to the docs, which is maybe something I shouldn't do in 2021, because docs for open source projects are really good now. Back in the late 90s when I started, there was nothing. You always looked in the source code. Okay, so idle is happening here, and it looks like physics process is happening above it. So this should be iteration, right? Iterations. This is main iteration. Physics advanced steps. Oh, okay. So physics, the physics timer thing, will only run physics if enough time has elapsed, or if too much time has elapsed, it'll run it more times, right? If it missed its chance to run it for the last frame because things went over, it'll run it twice really quick. I think that's what this loop is about. Let's see. Advanced physics steps. Yeah, I think that's what it is. We'll just make that assumption for now. Don't need to go down too many rabbit holes. Okay, and it does all the physics stuff. It does the 2D server. And it should do the 3D server too, right? Oh no, okay, so it does the 3D server first, then the 2D server. Does get main loop iteration, which is what we were just looking at, which only does physics process, and then later down it does idle, which is process. So, okay, my original mental model is good. I don't need to change my mental paradigm here. The clean, if you can find where you saw that in the docs, it is wrong. It's physics process first in the iteration. So maybe we could submit a PR to the docs and fix that. But looking at the code, unless I'm like totally misunderstanding this, I think it's physics process and then process. Okay. So does that change what we're going to do here? I'm going to say no. I'm going to say we're still going to try doing the internal physics process so that by the time we get to process, we can say your floating point position should be updated and you can mess with stuff. How are we doing on time? Ah, the time just flies. We have 40 minutes left. Let's see if we can get this thing working and see what kind of performance benefits we get. That is my goal. 40 minutes. We've got it. The clock is ticking. Okay, so SG fixed node 2D CPP. All right. So what we need to track is if we have changed something that should need to be updated. So we're going to need like a property here that's like if I am loath to call it if xform dirty because like I literally know that that's a property on node 2D. So we'll call it if fixed xform dirty. Then we will copy from our fixed transform to the normal transform. So we'll do like set transform fixed transform. And I think, yes, we can do this to float. And then we'll set fixed xform dirty back to false. Of course, this variable doesn't exist because we haven't created it yet, but we will. All right, so then we need a bool here for fixed xform dirty, and while I've got it in my brain, I'm going to add it to the constructor because I forget to do that like 90% of the time. And yeah, we'll just put it here, fixed xform dirty equals false. And now we need to say every single time we are updating one of our fixed properties, we'll start with just position. We need to set that to dirty and then not do anything else. Okay, so set fixed position, is this the place? No, this is something else. At some point I need to like go through here and clean up like these almost duplicate methods that exist here. It's not a priority right now because that does not affect performance. Okay, so set fixed position. This is the no. This is not the thing that is getting called. Okay, so in our test, we are directly modifying the fixed position vector, which goes through that whole changed cycle, the thing we just built. So that's down here. It's this fixed vector 2 changed. We get here. This needs to just not happen. And in fact, we don't need to check either of these because it will be exactly the same for scale and not scale. So, right? Is that right? No, it's not exactly right. Okay. Don't get ahead of yourself, David. We'll just get rid of this code. I guess I'll just comment it out for now. And we're going to do fixed xform dirty equals true. And that should work, right? I'm not missing anything. This should be an initial test of this. I might want to update it in some of these other fixed position methods just so that you know, I'm not accidentally forgetting the thing that's doing the thing. Fixed x form dirty equals true. Comment out this stuff again. Oh, and actually, hang on. We forgot to do our updating transform thing. We have these guards that we put around every time we are updating something on the floating point transform so we don't end up in an infinite loop. In the editor, if you update the floating point position, it will update the fixed point position, and if you update the fixed point position, it will update the floating point position. It's not that way during runtime. It's only one directional during runtime, but in the editor, it's bidirectional, and we need to not loop forever when we do that. Okay. So that should be good. Let's get... Yeah, that's just calling into the thing we already were doing. Set fixed position. We can change this now to do fixed x form dirty equals true. And we still need this change notify. So something I liked about the change notify, so the change notify will trigger this to happen, this changed callback, which again only happens in the editor. But I liked how I kind of had a way to prevent it from running, which helps our benchmarks. It won't matter for production though, so maybe I shouldn't worry about that. Change notify. Everywhere we're setting fixed position, I just want to change so that I know we're not missing anything, so we're not getting a bad test here. And this, yeah, I'm not going to change it everywhere. I'm not going to worry about this. I have all these like underscore accessors, which I had to add just because of a scene loading thing. So let's ignore that for now. Okay, I think we're good. Let's compile it. Let's compile it and see what happens. Compiling. Trying to think of more Godot-ish things to talk about in the meantime. We already talked about Godot 4. I am very much looking forward to being done with this project and getting back to working on VR stuff. I would not complain at all if suddenly I had to do what I was talking about before and like completely drop everything and try to work on porting WebXR to Godot 4. That would be super fun. Oh, speaking of VR, did anybody watch Facebook Connect yesterday? It was not as exciting as I was hoping it was going to be. I was hoping they were going to give us like real details on the high-end headset that Oculus is going to be releasing, but they gave us nothing. Scant little details. Still, it was still fun. I still enjoyed it, especially Carmack's brain dump. Ooh, okay, we broke it. We broke it. It's not working. I'm very much enjoying the timings that we're getting, though. Great timings when it doesn't work. Okay, so what did we do wrong here? What did we do wrong? We might have to do some breakpoints. Which actually, yeah, let me gear up for that right away. Let's change. Oh, do we have to like enable that we have an internal physics process? We might. Let's look at I guess that would be a node. So node set process. Okay. Set process internal. Do we have to enable that before it will work? I'm betting we do. What's the default for this process internal? Let's just try it. Let's just try it. I'm too obsessive with like digging into rabbit holes and getting the right answer and not moving forward. Let's just try it and maybe it'll work. So where was that? We would be in fixed node 2D CPP, and in the constructor, we'd want to be like, hey Godot, we have a sorry, I just need to cough. Let me drink some water. The risks of sitting and talking for so long. Okay. Let's initialize all the variables, and then at the very end, set, what would that be? Internal, process physics internal, nope. Set process, physics process internal? Physics process internal, true. Okay. Let's give that a shot. So yeah, I'm excited about, there were some interesting game announcements at Facebook Connect, which I guess we're going to have to start calling Meta Connect, since Facebook changed its name to Meta. There's the Grand Theft Auto, I think it was, which Grand Theft Auto it was, I can't remember right now, but not 5, it was 4 or 3 or something, coming to Quest, which is going to be exciting. I'm a little bit worried about the motion in that game, though. Like, I get VR sickness, motion sickness really easily, but still, it's exciting to dig into. I guess just like the pie in the sky commitment that they have to making AR and VR work is interesting, and I guess that's what they're focusing on the most. But I want that pro headset, assuming it's if it is below $1,000, I will probably come up with some way to buy it. But if it's more than that, because there are headsets more than that, there are like $2,000 headsets. I'm not buying a $2,000 headset. So like, what I want to know is this a thing that David might have, or is this a thing I'm never going to have? And then I will adjust my expectations accordingly. All right, cool. So this worked. We are getting really fabulous timings. Look at this. Assuming you guys can see that well, we are getting a cumulative average of around 3 microseconds with like runtime averages here between the sort of 2 and 4 area. I guess we had one time where it took 44 microseconds. I have no idea why, but that's fine because all these averages are really consistent, really level. One of the things that I noticed when I first started profiling this was that it was taking 13 microseconds on average, but it was jumping all over the place, where it'd be like this time it took 13 microseconds, and then 2 frames later it took 50 microseconds, and then 2 frames later it took, 13 microseconds again. And so I love how consistent this is, and I love how low this is. This demo is not a good measure of did this really help us or not, because we're not rolling back. We are still only executing this once per frame. So to really know if this helped, we need to go back to Retro Tank Party and try it out there. So let's boot that up. Let's switch over to Retro Tank Party and see what we're getting here. So I had a branch where I like completely disabled physics, which I think would be the best way to test this. Maybe we can do a halfway thing, or maybe I can find what that commit was and revert it. Oh, what are people saying? Bunch of wishful thinking and pre-rendered content. Yeah. that really describes Facebook Connect. San Andreas, yeah. So I'm excited for that. I never actually played Grand Theft Auto San Andreas. Nisha, looks great. Thanks, Nisha. Yeah, I should have celebrated more. I always forget to celebrate. This is this is just the way I am. Things go wrong, and I'm like, it's so deep and complaining, and then things go right, and I'm just like, yeah, it went right. No, that worked. That's awesome. So I need to celebrate that more. Yeah. How many microseconds did it take me to save those 3? Notification ready. I don't know if notification ready only happens once after you are added to the tree. We need to have this happen, you know, pretty often. So I'm not sure notification ready is the right place. But I think what we've got works. I think we need to try it. Let's okay. Let's just straight up try it. First of all, make sure it doesn't crash. And then let's try and see if we can isolate the performance improvement here. All right, things are working. You know, those, whoa. Things are not quite working. Do you guys see that? The explosion is like in 2 places at once. Yeah, that's wrong. So there's the question of, did we just cause that? Or was that a bug that we had from something else? I feel like we just caused it. Let's do a test here. So, okay, what do we have in... Oh, geez. I wasn't doing enough kind of commits and stuff. I wasn't doing any commits. So, okay, we'll have to do this a little trickier. I was hoping I could just do like a quick git thing to turn off what we just did, try it, and then turn it back on and see. So let's mess around a little bit here. So I copied over the new stuff, and we will just make a commit with this. Let's say attempt to only update floating point transform right before rendering. And then what we will do is we will switch back to the commit before that. And we will copy backwards the code from SG physics 2D into RetroTank Party and recompile. I think that makes sense. Godot modules, copy. All right, now let's get rid of that. Close this up. We're going to change our launch JSON to launch RetroTank Party instead of our physics demos. And let's build this. This will take us back to those right before those changes that we just made, and we'll see if we just caused the problem. Oh, Ricardo, I get what you're saying. I mean, set internal physics process on ready. Yeah, I think that'd be fine too. I'm curious what the rest of Godot is doing. If Godot is if other where other nodes are setting that. Let's find out. So let's grep for set physics process internal. I think that's what it's called. And see what we get. Hey, Boyan D. Welcome. I like how Boyan, who has a what I would guess is from a Southern Slavic country, greeting us with a Spanish greeting. Yeah, Nisha, I think it is at the last location. I think that is what we're seeing. Ooh, I didn't mean to load right in here. I wanted to load into the editor, but this is fine. This is fine. Or no, it is the editor. Okay, cool. So yeah, we might be not. What just happened? Something has gone terribly wrong. Let me get this up here. I think we might just be like setting it a frame late or something like that, or just a moment too late. Let's find out though. So we switch back to before we made that. Yeah. So we're updating it a frame too late, or maybe not a frame, but like we're updating it after the next time it renders. Let's try to find the right place for this. Da, 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 da. So where to look? Where to look? I guess let's look back here. I guess we want to see when does the visual server do its stuff? Visual server get singleton draw? That sounds like when we're drawing, right? And I mean, it appears like idle and all this stuff is happening before that. Part of this problem too might be the thing that we recently added where we are reusing nodes. So like, oh geez, too many things, too many instances of the editor here. Cancel, bail, stop, reload. I don't know, just I don't want you here. Go away. Quit editor. Yes, quit. So we added that thing to Spawn Manager to reuse old nodes. So it's probably reusing the explosion. And it seems as though we are like showing it, and I'm sure we're changing its position. We're changing its fixed position, but then the actual position isn't updating until later. So let me look at the code for that. So is Spawn Manager instance scene, blah blah blah. Spawn that's instance scene. We run network spawn. So network spawn would be the thing that actually sets the fixed position, which could happen at any time, right? But probably during a network process, which is physics process. Wait, okay, remember this drawing? And I was saying like, okay, so physics process will happen here before physics process here, but we're not using physics process. We're using physics process internal, right? And physics process internal is always run before physics process. Okay, so let's just change that. Let's change that one thing. Let's try changing it to we'll just change it to the normal physics process. So let's get it just kind of sucks now that I'm imagining like, well, what if a node like decides to say it doesn't want to run its process and like everything's going to break. But whatever. Well, that might be something we can solve via documentation or warnings or something. I don't know. But let's go to where is this? Oh, right. I reverted. So okay, let's check out perf. We gotta switch the code back. So now this code should match what I'm thinking. Yep, there's the notification. So let's switch to physics process. Notification. Or maybe process, maybe internal process is the place to run. Because internal process will come before rendering, right? And after physics process. Let's try that. Let's give that a shot. So we need to do set internal, set process internal true. Okay. And did my grep come back about where everyone else is doing this? So let's just go to, let's look at camera. Or, I don't know, I'm about to open in Vim. Habit. Let's open it up here in Visual Studio Code. Let's see, set, it was physics process internal. Oh, okay, so it has a camera mode property where it's could be one or the other. Fine. That's this is not a good example. Timer has a mode to raycast 2D. Set physics process internal. Well, when does it do it the first time? Because this is when it changes, but when does it set the first time? On enter tree. You know, we want that too. Ha 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 ha. Wow. Thank you, Ricardo, for making me go down this rabbit hole here, because yeah, we actually don't want to process if we're not in the tree. We have a whole bunch of stuff where network process doesn't run if we're not in the tree, so like we don't want to run if we're not in the tree. So, oh, and also this stuff with the editor, that's fine though. Oh, we do have to test this in the editor, because we also update the fixed position in the editor and expect that it should update the floating point position, and hopefully that still happens in the editor. Yeah, we'll have to test it. So, really quickly, we're testing two things now. Let's not test two things at once. Let's just do this, and we'll see if this works. And if it does work, then we'll come back and we will fix the thing where we are setting our turning on whether we process or not, whether we are in the tree or out of the tree, because I think that's the right thing to do. Yeah, I just picked up Resident Evil 4 for the Quest, and I haven't played it yet because I'm terrified. I played through Half-Life Alyx like 1.5 times or 1 3/4 times or something, and I love that game, but it is so scary for me. I do not handle VR horror games well. They're terrifying. But like everyone is saying Resident Evil 4 for the Quest is so good, I just feel like I can't not play it. You know, like if everyone's talking about it and everyone's saying it's great, I'm going to be missing like this piece of like VR gamer culture or something. So I'm going to try and convince myself to play it tonight or tomorrow night, and hopefully not completely lose my mind, give myself PTSD or something. Okay, so let's give this a try. Hey, hey! Okay, that is working. Beautiful. So we were just we were accidentally running before the sync manager's physics process instead of after, and I think this is fine. I think this is fine. We could have it be on normal physics process, but then it could get turned off. Having it on process internal means that we should happen after physics process, but before normal process, which is perfect. That's perfect. That's the perfect place in the game loop iteration to be. So sweet. Let's finish this. We have the main thing in here. Let's finish this out, not just for updating position, but also all the other properties. And the thing we just learned about entering and exiting the tree. So yeah, your instinct was right, Ricardo, thinking it should be during on ready, like this is enter tree would be before onReady, but it's the same kind of thing. Like we're not doing it until we are sure that we're in the tree and we're going to be doing stuff. So notification enter, is that tree? Enter tree. This will be set process internal true. Notification exit tree. Yeah, it's honestly like streaming development is a weird mixed bag. Like honestly, like I code worse when I am on a stream. I type worse, I code worse. But all of the ideas from you guys that you get that you're giving me, the different input and all of that stuff, the added hive mind means that I end up going down paths and considering things that I otherwise just wouldn't, and I think overall makes the code better. Even like I'm operating at 60% efficiency, but you guys are operating at 100%, and there's more of you than there is me. So this is really cool. I love streaming game dev. Okay, so we have that enter exit tree thing, and now we need to go through the rest of these properties and make sure we are doing things the same way. So we are not setting the float transform. But we need to remember that we are definitely setting xform dirty, the fixed xform dirty equals true. I see some comments. I'm going to attempt to resist the urge to read them until after I've gotten through this one thing. Oh no, it's appearing on the screen. Okay, so xform dirty. We need to get past all. Wait, scale changed. Set fixed scale. Yeah, that's fine. Let's get past here. Set fixed transform. Okay, we already updated the thing that it's calling. Fixed position. Set fixed scale. Set scale. We're gonna get rid of. We're gonna get rid of all of this. Well, except not the change notify. Say xform fixed xform dirty equals true. Okay, so rotation. So we need the change notify to happen, and fixed xform dirty equals true. And global fixed position. That doesn't do anything extra. That might be all the spots. Might be all the spots. Oh, and here. Well, that calls set fixed rotation, and we just updated set fixed rotation, so that should be good. Let me just verify. I'll jump into here. Yes. So we'll just do a quick sanity check. We'll search for set position. Nothing. Set scale. It's on the internal transform. Okay, that's fine. Set rotation. That's on the internal transform. That's fine. Okay, I think I got all the spots. And the question is, will RetroTank Party still work? Because it updates all of those things. It updates rotation. It updates, full transforms, everything. And we want to make sure it still runs. So let's compile that and test it out. Ricardo, with internal process, can't it run more than 60 times per second? Yes. Yes, it can. But I think it's fine because we just need to make sure it runs before the next time we render. And it won't do anything if fixed xform dirty is false. So I think that's okay. It's not ideal, but it should be okay. And if for some reason someone updates the fixed position, like not during, I was gonna say if it's updated not during physics process, but that actually won't help. That's not true. This is making me think we need a manual method to do this too. So it will automatically do it at this time. But I think we need a manual method too, because what if someone wants to update it somewhere else. Like if they're in their process method and they want to update the fixed position, which could be. I mean, for us, we care about physics process because that's like how our sync manager works and all that stuff. But the physics engine could be useful in other contexts. So I think we need to make sure we add a method to manually do this as well. Yeah. So great question, Ricardo. And I think we're okay for our purposes, but that definitely leads me to believe that we need to add something new. Okay, so this is working. We didn't break everything. And yeah, let's just add that like manual method. How are we doing on time? Oh, 5 minutes, and we're on the verge of accomplishing a thing. Was there anything else in this that we needed to do to call it complete? I don't think so. I don't think so. I mean, I guess I would love to be able to get some measurements to see like how much this has helped us. And so maybe that's the thing to focus on in the end here. Spend our last 5 minutes trying to get some sweet metrics. Although adding a manual method to just like update the float transform should take like a second. Not a second, but you know, quick. So let's do public method. Let's say void update float transform. Not const, we are changing things. I put that way down here. Above this one, so void sg fixed node to d update float transform, and we need to do the thing we did here, which I think should be super simple. And I'm just going to do I want to call another method, or do I want to inline a thing? I'm going to inline it. I'm going to live dangerously, although maybe the dangerous thing is calling the method. And do we want this to always do it, or only do it when the X form is dirty? Maybe we want to only do it during the X form is dirty, because we know if it's dirty or not. So maybe this should be the whole thing. There's no sense in doing a thing when we know it will have no effect. Okay, fine. Fine, unoptimized universe. I will make it be a new method and call it. I don't need to get too obsessive about not having too many function calls. So update, float transform, and then we just need to bind this. So it can be called from GDScript. So update, float transform. Oops. Update, float transform. Beautiful. Okay, so that is the last important code change in C++, I think. Then we're going to compile this. We're going to poke around in Retro Tank Party and try to get some good metrics on this. I did at one point have everything set up to test just the bullets moving with no physics and how much time that was taking. We'll see if I commented out that code and if it's still laying around, or if we're gonna have to like revert something, or maybe we could just hack something together really fast to see what the timings are on it. But this is good. This is good, folks. We went from something that was super all over the map and taking 13 microseconds on average to something that is taking, it seems like around 3 microseconds. So this is good. That we did that math earlier. Like, how does this look in terms of that math? So if we're taking 3 microseconds and we have 10 bullets, you're in my way, terminal. I guess I'll just hover my mouse up here for a second while we wait for Godot to start. Okay, so 3 times 10, so that's the number of microseconds we're spending on this during a single tick. and then we multiply it by 15, or let's say 20 for the worst case, although we're actually using 15. We'll do both. So 3 times 10 times 15. Wow. Wow. So we took something that was adding up to 1, 2, 3-ish milliseconds and have it down to something that is in the hundreds of microseconds. That is huge. That really helps us with our frame budget. Let's see exactly, or not exactly, but let's try and see that in action. Let's see that happening. So where should I be looking? I should be looking in bullet. Maybe it was base bullet? No, it was bullet, normal bullet. Right, so this fixed position I add. So what I did was I like took this away and took this away, and so now the bullets won't ever collide with anything. They won't ever update their position in the physics engine, which is where the broad phase and all of that stuff comes into play, right? Because if I go, I can't jump to it when it's counted out. Okay, so check collision. Where the heck are we updating this in the broad phase? Like, I didn't see it. Oh no, here, okay, here we go. Sync to physics engine. Okay, yep, that was where we're updating in the broad phase. Okay, so this top one is checking for some collisions, which is querying the broad phase and doing all of our normal collision checks. And this is updating ourselves in the broad phase. So we're taking those completely out of here. And we want to know how fast this network process is running. I think I have something in Sync Manager that was collecting timings for that, which I either commented out or like just completely removed. I don't remember. So that would be in call network process. Oh, back up, back up. So here's where we're going to get these measurements. Yeah, and so when I tested this before, I was seeing occasionally getting like 100 microseconds for bullet updates, which seemed just dumb. Just seemed like, why does it take so long to move a bullet by a vector? And we're gonna try and get an idea of the timings we're getting. This is gonna spam the console, and it's gonna be hard to interpret and all that kind of stuff. But you know, let's give it a shot. We'll gather some data. So I don't know if you can see the frame rate's a little weird, but I think that's because of the spamming the console. So I'm going to do this for a little while, and I'm going to kill it. And we're going to take a look at what we got. Yes! 50 microseconds. There's just a bunch of function calls and some indirection. 74 microseconds. Overall, we're watching, so the important thing here is this rollback number. It's doing 15 rollbacks every frame because it's in a debug mode to do that. So we care about the rollback number, we care about the current tick number, and of course the frame total, because we have a frame budget of around 30 milliseconds, right? Because the whole frame is 33 milliseconds, but we don't get all of it. Of course, the audio server needs some of it. The visual server to do the actual rendering needs some of it. So we want to stay as much as we can well below that budget. And of course, this is one player with like a small number of objects. So we got to, like, in this test, we want to be way below. And we're not quite way below. We're staying below, and we're seeing some really sweet timings on these bullets. I guess here's what I want to see. I want to look for a time when the frame took particularly long. So this was one that took 29 milliseconds. The rollback took 22 milliseconds, and I want to see that the bullets are not a huge part of that, right? So I look at the bullet here, that's 60 microseconds. That's beautiful. This lifetime timer, you might wonder, why does a timer take so long? And I did too when I was going through this. It's because this time includes the time spent by the things that caught the signal that the timer went off, and so that's why it goes up to 500 milliseconds. So this must be like spawning the explosion. Like that time is all for spawning the explosion. But yeah, the thing that's making this take a long time, is not the bullet. The bullet is now a minor player in this whole affair. So yeah, I think this was a success. This one piece of profiling paid off, got us there. We have a lot more stuff to address, like I was talking about before, the broad phase and the move and collide, move and slide stuff. And those will help with some of the parts that we commented out here. Or we'll uncomment them out from bullet. And we can take a look at those timings a little bit. Ricardo says, nice. Kill it. Okay. And so now the bullet should take longer because we are querying the broad phase and updating the broad phase, but hopefully not too much longer. Yeah, actually in some of these cases it's looking about the same, right? Like look at 72, 56, 53, 71, 71. So I mean, yeah, you can see a marginal increase, but like this is actually kind of more marginal than I would have thought, with having to do stuff in the broad phase. So what were the areas? There were, in the move and slide and move and collide. So the broad phase stuff will help everything in physics. Will make everything that we do with physics a little bit faster. Primarily though, move and collide and move and slide, because if you folks remember when we were implementing those, they basically just like do a lot of physics queries. So move and collide, why am I searching there? I want to find SG kinematic body. So this is our version of kinematic body, and move and collide is basically like, so we start out by making sure we're unstuck, which can be up to 4 times we're moving and querying the physics engine. And then this sync to physics, or sync from physics, okay, that's fine. Sync from physics actually should be super fast. But then we get into the kinematic motion part, and we're going to move the body up to 8 times, which means 8 cycles of querying the physics engine, updating, which means updating a broad phase, then querying the physics engine, then updating the broad phase, up to 8 times, right? So anything we do that makes the broad phase faster will make move and collide and move and slide faster, which means the tank, which is the slowest component in the game, will get faster. And yeah, I'm hoping I can knock this stuff out this week, and next week we'll be able to do some play testing. I hope. Keep all of your fingers crossed, all of them, toes too, maybe. And yeah, we can get to the point where we're just squashing bugs to get this thing released. So thanks everyone. Thanks for coming to the stream. Super fun as always. Thank you for all of your comments and your help. And yeah, I'll see you on Discord and on stream next week. Take care, everyone. Have a good weekend.